This is problem 1 from the chapter 2 quiz 1. So it's given f of x is equal to that, and f times g of x is equal to that. I'm supposed to find g of x. So this problem kind of takes the form of this. If I had f of x equals a, and I had g of x equals b, then f times g of x would simply be a times b. Or if I'm going to look at it a slightly different way, if I had f of x equals x squared and g of x equals x, f times g of x would equal x squared times x, which is equal to x cubed. So if I was given f of x as x squared, and I was told, so f of x is x squared, and I was told that f of x, f times g of x is equal to x cubed, what I'm trying to find here is g of x. Well, how would I do that? Instead of a question mark, let's not put a question mark there, let's give it a variable. Or why don't we call it the variable p? Well, if I wanted to find p, I think what we would do is we would divide this side of the equation by x squared, and we divide this side of the equation by x squared. So I wind up that p is equal to x. Well, it's the same thing with our original f of x and f times g of x. It's just a little bit larger of an algebra problem. I have f of x, which is x squared minus 1 divided by x, and I'm multiplying it, well, let's use the same variable, I'm multiplying it by p, which I'm using instead of g of x, and I know that that's going to be equal to x squared minus 2x minus 3 over x. So I could have removed this p right here, and I could go back and call it g of x. So I have right here, I have f of x times g of x is equal to f times p, f times g of x. So this right here is a setup of my problem. And now I have to figure out how to do the algebra. Just like in the problem, just like when we set it up a minute ago, if I have one term times another term, and I'm told that it's equal to a third term, I just divide by one of the terms, and I can find out the answer that I'm looking for. So let's go back to our big problem here and see if we can't do some of this algebra. I'm going to do, if I want to find g of x, let's erase this right here. If I want to find g of x, I have to divide both sides by f of x. So I'm going to divide this side by x squared minus 1 over x, and I'm going to divide this side by x squared minus 1 over x. Well, let's go back up here. So these two cancel out and become 1. And now I'm left with g of x is equal to x squared minus 2x minus 3 over x divided by x squared minus 1 over x. Let's go. Now I have this large one fraction over another fraction. So let's kind of again remember how fractions over fractions work. If I had 1 over 2 divided by 5 over 3, that's the same thing as saying 1 over 2 divided by 5 over 3. And we know we can solve that by going 1 over 2 times the reciprocal of 5 over 3. So we're turning a division problem into a multiplication problem, and that would give us 3/10. So I'm going to do the same thing here. Let's erase this, what I just did. Try to. Come on. Sorry. I'm going to take the reciprocal of my denominator and multiply it times my numerator. So I'm going to have g of x is equal to x squared minus 2x minus 3 divided by x times x over x squared minus 1. Now this is a multiplication problem here. And I see that I have an x on the bottom and an x on the top. So I can get rid of those two. So now I have g of x is equal to, multiplying straight across, x squared minus 2x minus 3 divided by x squared minus 1. This is an important juncture in the problem because a lot of people made the mistake of canceling the x squareds and winding up with negative 2x minus 3 over negative 1. But I have to ask a question. If I have 5 plus 1 over 5 plus 3, that is equal to 6 over 8, which is equal to 3/4. This is a binomial. It is two terms connected by a plus sign. This is a binomial. It is two terms connected by a plus sign. If I just cancel the 5s, my answer would be 1/3. But you can see really clearly that my answer is 3/4. Because this is a binomial, you are not allowed to just arbitrarily cancel out the 5s. The only way I'm allowed to cancel something that's in a numerator and a denominator is if it was, let's say it was like 5 times, or 5 plus 5a over 5. Then I could cancel out my 5s and have just a remaining. But that is the same thing as doing this. Changing this into 5 times 1 plus a over 5. And now you can see a lot more clearly that I can cancel out the 5. So in order to cancel out a denominator from a numerator, you have to be canceling the denominator has to go into every single term of the numerator. And 5 plus 3 as a denominator does not go into 5 plus 1 as a numerator. So let's kind of go back to our problem here. I have, this is no good. 2x minus 3 is no good. So I still have g of x equals x squared minus 2x minus 3 over x squared minus 1. There is something that I can do to simplify that. I am going to go g of x is equal to, and I'm going to factor my numerator. I'm going to go x minus 3 times x plus 1. That gives me, that is a factorization of my numerator. And that's divided by, well, x squared minus 1, that's a difference of two perfect squares, is x minus 1 times x plus 1. Well, now I have some canceling I can do because I have a product. I have x minus 3 times x plus 1, and I have x minus 1 times x plus 1. I can cancel out my x plus 1s, and I'm left with my answer, g of x is equal to x minus 3 divided by x minus 1. And that, in a box, is the answer to this question.